Okay, this is day 2 of lesson 3.2 for 7th grade math. The objective: students will define slope and determine the slope of a line from a table as well as from a set of coordinates. The standard covered is 7RP2B. The page numbers, once again, are pages 104 through 109 out of the hardcover book and pages 59 through 62 out of the practice journal. Today, instead of having a graph, we're going to go ahead and practice actually finding the slope of a line from a table. So we'll start out with the table, and what you need to realize is whenever they give us the table, we have to understand what is our x and what is our y, and they usually will identify that, but if they don't, and they set it up in this horizontal form, our x is always our top number in our table, and our y is always the bottom number in the table. And when we went through and we worked with rate in section 1, we worked where we would do that bottom number divided by the top number. And so we were practicing already setting it up that way. So when I go through to do this, what we're going to do is we're going to go ahead and find our rate by going through and doing our change in y. So change means subtraction over our change in x. So if I were to pick 2 of these samples, and it doesn't matter which 2, if I pick these 2, our change means to subtract. So one method is I could go through and subtract as long as I'm comfortable with integers, and I can work from left to right. So when I look at this, I would write it out this way. My y's are going to be on the top, so I have 0 minus 10. And my x's have to be on the bottom according to this. And the reason that is because really our y's, when we graph them on a graph, are our rise, and our x's are our run. So then for my x's here, I had 0 minus 2. So when I go through and I do the subtraction, 0 minus 10 would give me negative 10, and 0 minus 2 would give me negative 2. What's going to end up happening here is we end up with a positive 10 over 2, which can then be reduced to positive 5, or 5 over 1, however you would prefer to do that. I do have some kids that'll say, could I reverse the way that I subtracted those? So instead of writing it out as 0 minus 10, could I do it backwards and do 10 minus 0 and 2 minus 0? Yes, you can. You just have to make sure that whatever order you choose for one of them, you do them in the same order. So like here, I did the 10 first, and then I went to the 0 when I wrote it out this way. I have to do the same thing when I do my x's. I can't flip-flop. The reason being is that's going to change whether your slope is positive or negative if you flip them around. So here you would notice once again, 10 minus 0 is 10, 2 minus 0 would be 2. This would reduce to 5 over 1, which would be the same as just a 5 slope. And if you leave it as 5 over 1, that's fine. I do want to point out also, if I had picked 2 other numbers, maybe I worked with these 2. Same thing, if I set it up as a subtraction. If I prefer positive numbers, it's not that I can always avoid working with a negative, but like when I look at this, I say, it'd be easier for me to do 4 minus 2. So I could go backwards and do 4 minus 2, but remember that's going to be my bottom number, and here I am writing it as my top number. And then I just have to remember that I do my 20 first and then my 10, so 20 minus 10. When I do this, I still get 10 over 2, which is the same as 5 over 1. And when you do these, you should always get the same slope. So you can pick any 2 points. I would recommend picking 2 points that are next to each other. It'll possibly help in terms of having you to have to reduce it. But as you could tell from the first one, we still had to reduce. So it's not always going to avoid you having to reduce the number down. Okay, so let's try another one. Okay, so when I look at this, I have my distance on a map x and the actual distance. So this is working with some ratios and a map. So we need to do our change in y and our change in x. So our change in y is our difference, and our change in x is our difference. So I'm going to go ahead and put my y's on the top. So I'm going to work from right to left. So I'm going to do 50 minus 25 because those were my y's. My x's, remember, since I worked from the right to the left, I have to do the same thing with my x's. So 20 minus 10. And the reason I'm choosing to do it that way is just so I don't have to work with negative numbers. But once again, you're not always going to avoid those. So 50 minus 25 would give me 25 over 20 minus 10 is going to give me 10. So 25 over 10, I'm gonna have to reduce down to get my final answer, which when I reduce that down, I don't want a decimal answer, I just wanna reduce this to lowest terms. So 5 would go into each of these, which is gonna give me 25 divided by 5 is 5, 10 divided by 5 is 2, my slope would be 5 over 2. If I took on my calculator like we did last week, we would do 25 divided by 10, and that would give us 2.5. But we have to remember that with slope, if it's asking for the slope, we have to leave it as an improper fraction. So we can't use 2.5. I would have to then be comfortable changing that to a mixed number and then once again changing it into an improper fraction. Whereas here, if I just work through and reduce it by the same number, I don't have to change and do all of those extra steps. All right, let's try another one. So remember, it's a change, which means we're going to subtract. Okay, so gallons and miles. So I'm going to guess this is miles per gallon that we can get. So our change in Y. And yes, we're working with some decimal numbers. And some of you might say, oh, I don't like to work with decimal numbers. We could pick the two sets here if we wanted to. It's just we're going to have to be comfortable with reducing because when I go through and I use those, I know because they're not right next to each other that with 100% fact that I'm going to have to reduce them down. So, which is okay. I'm going to go ahead and do subtraction between these. So I'm going to put a minus sign just so I remember I'm subtracting. And I'm going to go ahead and do my right first minus my left. So that's my bottom, 20 minus 10. And the top is going to be 650 minus 325. And the reason I chose those two is just so I didn't have to work with decimals. So if I do 650 minus 325, and of course I could use a calculator if I needed to, it's going to give me 325 over 20 minus 10 is going to give me 10. Now I'm not going to punch in 325 divided by 10. If I was doing the rate in decimal form, yes, I could do that, but they want to know the slope of the line, so I have to leave it as an improper fraction. So when I look at this, 10 won't go into 325, but 5 would go into each of these. So if I reduce by 5 over 5, 325 divided by 5, I don't know that off the top of my head, but I know there's 20 and 100, so 40 is 200, 60 would be 300, and then 5 more, so 65 over 5 divided by 5 is going to give, 10 divided by 5 is going to give me 2. So that's the slope of my line, okay? Had I used one of my decimals, just to kind of show you what would happen, let's say I just used these two, which would be fine, but here's the thing, a slope of a line should never have a decimal in its answer. So if I had used these two, and I'll use a different color just so that we can see the difference, and I had done 325 minus 162.5 over 10 minus 5. Okay, so now when I go through to do this, the bottom number is going to be 5. The top number, 325 minus 162.5, I think is 162.5. Let me double check it quick. It is, so I get 162.5. I cannot leave a decimal number in a slope, which means I would then have to take everything times 2 to get that decimal out of there so that it could become a times 2 would round that to a 10 and then bump up. That's why I chose to pick the two numbers that I did so I didn't have to worry about having a decimal in my final answer. Okay, so here the true final answer should be 65 over 2 for our slope. Okay, and I know, yes, you could reduce it down and say something over 1. And if I did the 162.5 divided by 5, it ends up giving me 32.5 over 1. But once again, I can't leave a decimal in my slope, which means I would have to double that to get that 0.5 out of there, which is going to end up taking us back to the 62 or 65 over 2. Okay, so when you see decimal numbers, you have to, if they give you some where there's whole numbers, work with the whole number sets. Okay, so that's working with the table. So the key thing to remember on the table is it's set up backwards. You have to remember whatever's on the bottom, because that's your y's, that's gonna become the top of your fraction, okay? Okay, so the other thing we're gonna work with is when I give you a set of coordinate points. So we have to review really quick. Once again, we're gonna take our y minus our y, that's our change in y, and our x minus our x. So the first thing we have to understand is when we look at these, we have to be able to determine which is our x and which is our y. So if you remember in the alphabet, when you say the end of the alphabet, you say X, Y, Z. X, Y. It goes in the same order. This is my X, this is my Y. And I have color coded them for you, but obviously on a worksheet or out of your book, they're not going to be color coded. You're going to have to be able to understand which is which. So now we're going to do our change and our Y's. So here's our Y's. Now I'm going to circle them, so I'm only focusing on those. And yes, I threw integers in. So you have to make sure that you are remembering to put that minus sign in between. So I'm just going to go ahead. I'm a left to right person, so I'm going to work left to right when I possibly can. In this situation, it's not going to avoid me working with negatives anyway, because both of them have a negative sign. So I'm just going to do left to right. So my y's, I have a negative 12. And I need to remember I have to put this minus sign. That's the most common made mistake when there's negative numbers in our coordinates. And then minus 3 is my other one. Okay? If I do my next set, left to right, I had 6 minus, and then I had a 15. Okay, and I was getting those from right here. So now when I simplify, this is going to become plus 3. So now if I need to use my calculator, I can, but I'm hoping you don't need that. I have a negative and a positive. Those are different, so I'm going to find the difference. The difference would be 9. The larger number is negative. And then 6 minus 15, once again, a positive and a negative. I have to find the difference, which would be 9 again. And the larger number was negative. So I get an answer of negative 9 over negative 9. 2 negatives make it a positive, 9 over 9, or positive 1. Okay, and these just take lots of reps. I know the first few times that we practice through them, it's kind of confusing, but pretty soon you get more and more comfortable with them. And you'll use these a lot next year. So I'm kind of just giving you that practice right now to kind of give you an idea of what we're working with, and then you'll work with them even more next year. Okay, so change and y's. So we're going to subtract between our y's. So here's our y's. Remember, they're the back set, so I'm going to just work left to right on this. 2 minus 5. Okay? Over. Here's my x's. So 12 minus negative 7. And this is the most common made mistake is kids, because there's a negative, and I'm guilty of it myself. Sometimes I get going too fast. But because there's a negative on that 7, they forget to put that minus or that change part in there. Okay, so now when I look at this, 2 negatives make that a positive 7. Okay, so when I do my subtraction, 2 minus 5 is negative 3. Over 12 plus 7 is 19. So my slope is negative 3 over 19. Okay, so I want you guys to pause your video and practice setting this one up, and then we'll work through the final answer together. So go ahead and pause your video and work through setting up this equation with your y's on top, the change included, and then your x's on the bottom. So you should have had 8 minus 16, or if you're somebody that reversed it, it should have been 16 minus 8. And I'll show you that if I had done these right to left, it would look like this. And it doesn't matter which order I do them, as long as I put my y's on the top and I do my second set in the same order. So this time I would have to do my 9 and then my 20. You're going to see that when we do these, we still end up with the same answer. So when I go through and I do the original one that I had here, when I do 8 minus 16, it's negative 8, over 20 minus 9 is 11. So that's actually a slope of negative 8/11. When I look at this next one, the one where I wrote it backwards, 16 minus 8 is 8. 9 minus 20 is negative 11. It's still the same thing. We still have one negative on that fraction. So it doesn't matter that one of them's in front of the 8 and the other one's in front of the 11. It's still negative 8/11 for our whole slope. Okay, you just have to make sure whatever order you choose for one of your sets, you have to do the same order on the next one. All right, let's try one more. Okay, so I want you guys to go ahead and set this one up. This time I did not color code. So you have to remember, just like in the alphabet, it's X, Y. So go ahead and pause your video and work your way through this one and get down to your final answer, and then check your steps with mine. So you should have ended up with -2 or -2/1. If you had 20 over -10, that's correct, but you just needed to get it reduced down. And remember that negative applies to the whole set. All right, well, that's it. Good luck with this. And just remember with those X's and Y's, make sure that you're doing your Y's on the top, the change in your Y's. So you're subtracting between your Y's, and then your change in your X's on the bottom. And remember to keep them in the same order.